Welcome back. I have a quick lesson, hopefully quick, on angle relationships in circles here. Before I get to it, though, I want to review really quickly what we learned in the last section. It was on inscribed angles. So an inscribed angle is an angle that is inscribed in the circle like this. And we learned that there is a relationship between an inscribed angle and a central angle. So a central angle goes from the center of the circle, whereas an inscribed angle goes from the outside of the circle. So both of them have the exact same length arc. Let's make something up here. Let's say that this is equal to 70. We know that the central angle is the exact same angle as its arc. And we learned last class that the inscribed angle is half of that. It's going to be half the central angle, or half the arc that we measure. So this lesson we're going to look at something different. We are going to look at points outside of the circle, or angles outside of the circle. So let's take a look at this black one first here. So we have this point outside the circle. So I'm going to call this X. And it has a special relationship, just like the inscribed angles. And X is equal to 1/2. We'll call it the big arc minus the little arc. In this case, the big arc is going to be, we have two tangent lines here, so it's touching the triangle at a point here and a point here. So we have a big arc here. That'll be our big arc. And we have a little arc here in our circle. That'll be a little arc. So this angle is going to equal half of the difference of those two arcs. All right. In the next problem here, in the next drawing, we have two secants. They're going through there. And it's actually going to be the exact same formula. We have 1/2 the big arc, 1/2 times the big arc minus little arc. In this case, if I say this is X, my angle, my big arc isn't quite as big as before, but we have an arc from these two lines, and then my little arc will be right here. So we have big, we'll call this little. Alright, and the last one, we have a secant and a tangent. So if we're looking at this angle X, it's going to be the exact same relationship as the first one. It's going to be 1/2 times my big arc. Now my big arc is going from here to here, and my little arc is here to here. So little, big. Alright. Let's take a look at a problem that uses this. So here, kind of like the last one, we have a tangent line. So this is going and touching just one time right there. We have a secant which crosses twice. So our formula we use to find this exterior angle here is 1/2, say the big arc minus the little arc. Alright, so the big arc is 108, right? 108 minus the little arc is 64. So we can say X is equal to 1/2 times 108 minus 64. Let's see, 36 plus 8 is 44, I believe. And 1/2 times 44 is equal to 22. So this angle here would be 22 degrees, which is smaller than my little arc and my big arc, which will always be the case. Alright, moving along, we have one last thing to learn, which is a pretty easy concept. here we have two lines that are intersecting inside of a circle. All right. So if we know the measures of the two arcs, the angle inside the circle is equal to the average of the two arcs. So the angle inside the circle equals the average of the two arcs. So x will equal, I'm going to find the average of 80 and 46. So that would be 80 plus 46 divided by 2. 80 plus 46 is 126. 126 divided by 2 would be 63. So this angle would equal 63. Hopefully you remember from a long time ago that this angle x here and this are vertical angles, and they would be the same. And if we want to know this y here, it would be supplementary with 63. So when I added angle x, the 63 there, to the y, I should get 180 degrees. So that means this angle y must be 117 degrees, because 63 plus 117 has to equal 180, because they make a straight line there. This works for any circle with lines intersecting. So if I make a circle, I have two lines that intersect here and here. If I want to know this angle x, it's going to be the average of the two arcs here. So that arc and that arc. If I want to know, say, this angle y, it's going to be the average of this giant arc and this arc here. All right. We'll see you in class. Hope you enjoyed.